My name is Leif Holm-Tambia, and I am product owner of energyPRO, or product manager of energyPRO. So I'm in charge of coordinating the development of energyPRO, and so this is also why I'm presenting this version of energyPRO 4.9. So I'll just get started with my presentation here. The agenda for today is these 5 items, which are the main things we have included in this version of energyPRO. We are mainly talking about the optimize module, where we have added more technologies. And next, we have made an improvement in the batteries, where we can now make formulas. Peak payments also included in the MILP calculation. And then on the time series, we have added some nice options of scaling and offsetting, and also last option of setting a color on the time series. Let me get started. So the optimize module we released back in November 23. And it is very much about sizing optimization. Whatever equipment you have, you would like to have an estimation of what is the optimal size. Until now, energyPRO has focused on the optimal operation of a given size of a unit. So, but for now, we can include what is actually the optimal capacity or size of this technology, or in the conversion unit, or storage, or whatever it could be. So the first version included most energy conversion units and thermal storage. For this to work, you need to use the MILP calculation. It does not work in the analytic. And it works the way that we calculate 1 year. For the optimization period is 1 year, not months, but 1 year. And then for each equipment you want to optimize, you specify an investment, then you specify an expected lifetime, and then an interest rate, and then by that we can calculate an annuity cost, which we add into the MILP optimization, and then that's included in the MILP optimization. With this version of energyPRO, we have now the option of optimizing the capacities on transmission, and that is both the default transmissions, where you specify the capacity, but it's also the hydraulic transmission, where you specify dimensions and lengths and so on. You can optimize your grid connection. You can optimize user-defined thermal storage. In the previous version, it was only the thermal storage defined by temperature differences and fuel storage volume. Also, fuel storage are included. And finally, a small thing that in the built-in heat pump, in the previous version, we could only you could only select the electricity input as what you to optimize. Now we can also have the output optimized based on the output of heat. Okay, let's go into energyPRO. I will just take one of my project examples and move into the screen. Here we are. So this is a small, rather simple model where we have a district heating grid with a heat demand, a gas boiler, and then we are connected to a solar collector field where we have a solar collector and storage. And then the question is, what is the optimal capacity on this transmission? Please ask. Now I'll just repeat myself, I think, but now I guess we are more or less all here. If you have any questions or comments, please add them in the chat, and then after each item here, we will look into the chat and see what questions you have, and also you can at that point ask questions directly if you feel like it. So if we look at this one, I have already made a calculation, and where I'm on the solar collector field, and you can see this green line here indicates the transmission from the solar side to the district heating side, and you see we are up to almost 20 megawatt of is transferred in this transmission line. But the question is, what is actually the optimal capacity of this line? So then on the transmission line, as it looks here, we simply specified right now a rather high capacity of 30 megawatt. But now we want to optimize that. So we enter the optimize window. And here you see, of course, you need to select the year for your optimization period. In this case, we are in a design calculation, so there's only the same year to use. But if we had a finance or accounts calculation where you have multiple years, you can select which year you want to use for the optimization. The interest rate used for the annuity, and then here you have all the different selections. This is energy conversion units, storages, and then this is the transmissions. And here we have this one transmission which are enabled. So you see it down here. Then we have the upper value, the specific investment, expected lifetime, and then we need to calculate this optimal capacity. So here we have the upper value. We have set this, in this case, to the 30 megawatt, which and then we specify an investment per megawatt. And in this case, it has been set to 50,000 Danish kroner per megawatt, and that is per megawatt. Yeah, per megawatt for the whole transmission. Let's make a calculation. Let's just press this button down here. Okay, so as you see, we ended up at a capacity of 7 megawatt. That's quite well below the 30 we have estimated as a upper value, the most we could have, but also quite below the 20 megawatt you saw on the production graphic. So let's have a look in production graphic once again. You see now you see this is a result of the optimized calculation. You see that to make sure you are aware that we have written this in top of the window here. So this is as a result of the optimized, and there you see that we now only have this 7 megawatt, and then we have longer periods with the transmission instead of. So now we all stay on the 7 megawatt. Now, of course, you shall be careful, because this specific investment was probably, if you assume that you had around 30 million megawatt of necessary capacity, and the thing with the pipe transmission is that the less capacity you have, the relatively more expensive does it become per megawatt. So that you should be aware of, and maybe you will need to make another calculation. But what I'll do now, I'll go to the next my next example, and that is with hydraulic transmission. Put it in here. So this is the model we include with energyPRO. And now we like to optimize the capacity of this transmission here. Once again, it's a solar collector side into the demand side. If we enter the optimize window here. Sorry, I'd rather go here first. So this now looks like this with the hydraulic settings, where you define a length of your pipe, you define a diameter and some roughness and a heat loss, velocity, max velocity and max pressure gradient, ground temperatures, and by that we can calculate what capacity does it have in megawatt, and the megawatt is what get into the MILP calculation. So this is the number which are entered into the MILP calculation. But now we want to ask ourselves, is this actually the optimal diameter, this 200 millimeters? So therefore we go to our optimize module window here. Once again, we have selected this transmission. We have specified what other value we would like to calculate, and here we have set 300 millimeters. Next, we specify the investment, specific investment, and now we are talking about an investment in euros per millimeter per meter. So now in this case we'll have an investment of 6.5 euros multiplied by 300 millimeters multiplied by, I think it was 3,000 meters. So that is the total investment. And what energyPRO does now is it calculates, based on these 300 millimeters, it calculates what is the capacity of this when we have 300 millimeters in megawatt. And then it takes the investment, the 6.5 multiplied by the 300 millimeter multiplied by the 3,000 meter. This investment is divided by the capacity in megawatt. And then we have a specific capacity per megawatt, a specific investment per megawatt, sorry. And then by the use of the interest rate and the lifetime, we calculate the annual annuity cost of that. And then that goes into the to the MILP calculation. So let's try to make a calculation here. Oh, that was not that lucky. But it did came up with a solution here of 130 millimeters. So that is quite far from the 300 millimeters. And what is the risk of now with this transmission calculation is that we need to make, now we should be aware that our specific investment might not be correct anymore. Let me just illustrate this by a few graphs here. First of all, down here we have a graph called euros per millimeter per meter also. But this looks like if when it comes up in this case, specific case at least, 75 millimeters around here, then the price seems to level out. So around 6.5 or something like that euro per millimeter. Below that, we have the price is a lot higher. But since we had we started out with 300, now we ended up at like 130 millimeters. So that's okay. But the problem is that we look at this graph up here. But if you look at the green curve here is down here we have the millimeters, and then we have the megawatts, and you see when we're at 200 millimeters have like something like 4 megawatt. 400 millimeters we have 22 megawatts capacity. So this is not linear. These two correlation between the megawatt and the millimeters. So this means that energyPRO assumed that we had a cost of 200 millimeter per euro per 200 euro per megawatt, this one over here. But actually, when we come down to having only 130 millimeters, our price is no longer 200. Now it's more 500 euros per megawatt. So this means to have the optimal calculation, we actually need to do a recalculation, an iterative process, do more calculations. So my process here would be to make a new calculations where I add the result of the previous calculation, because what energyPRO now does, it looks up 130 millimeters. What is that equal to in megawatt? And then it takes this megawatt and have the specific investment as well. And then we have a different price per megawatt than we had before. I will just take the chance and do another calculation and hopefully it will be a little bit faster. Otherwise, while it calculates, I think I will continue on the slide here, and then we can look back a bit later. I just have a last slide on this transmissions. Now that is more on the optimize in general. You should be aware. I also stated that at our webinar in November. But the optimize have we need to do some limitations to make it work. So on energy conversions units, all units, the unit is allowed to path load. So, and also if you have any path load power curves, they are ignored. So we only look at the max power curve, and also we ignore minimum load. Next, that we do not have an investment curve, and that's also what you kind of see here. We can put in one price, and for that you will need to do the calculation. And if you then end up in an area where this price is not really valid, you'll need to do a new calculation with the price valid in that area of the capacity. And as I've said before, the optimization period is a year, it's not monthly optimization, and the planning period is also a year. Let me have a look. Just a moment. Just need to do something here. Yes. So now you see it came in down. Okay, now it's 123 millimeters, and that way, of course, the jump is a lot smaller now. So maybe you can argue, okay, I'm about there, and also, of course, maybe you cannot have a pipe most likely on this specific diameter. You'll need to say, okay, it is in this area, and then you use an available pipe diameter in your calculation from now on. But afterwards, now the workflow is that you have these 123 millimeters, and you say, okay, now that is what I add into my the diameter here. So and then you work from there. Okay, we have some more optimized features I would like to show you. Just a moment, I'll put on this model, where I will try now to show the remaining things we have included. And what the remaining thing was the thermal storage, which now we can also include a thermal storage which are user defined. You can have this. We have now fuel storages, the hydrogen storage here. We have we can optimize this size here, this number. Finally, we can also optimize on the on your grid connection. Like here, we have added stated that we have max export capacity of 20 and import capacity of 20 megawatt. These values we can optimize as well. So let's see. In this case, I have added them all together. So we have now the thermal storage. I put in upper value of 500 megawatt hours and a specific investment, some lifetime, fuel storage, capacity of the import. And then I take the chance to make another calculation. Hopefully it will be a little bit faster. In the meanwhile, we can, have there been any questions or comments?
Yes, one question from Sophia, where she
Yes.
asks if, in regards to the optimization or the optimize module, if it's only, say, I'm just going to read it out loud. Can we only optimize based on a single year, or is it possible to optimize for longer periods of time? That is, can heat accumulation be optimized for a period of 5 years, where some production units are established and some others are taken out of use?
Yeah. No, yeah, the reply is at the moment, no. We can only optimize for one specific year. Then what you would need to do, I guess, the same optimization for different years, and then see where do I actually end up, what capacity do I end up with on the different conditions. So that would be the solution to that. We have in mind, though, I would say that we could potentially have more years included, but then we would need to have the optimization period to extend beyond this 1 year, which are the maximum today. And as you see, we can easily have a calculation taking quite a while, but it is not. We have ideas of saying, okay, why not try to include the whole period, or 5 years or 10 years, or and then see. I guess if given enough time, it will come up with a solution. So that potentially we could do that, but we are not there right now.
Thank you.
Welcome. Anyone else? Questions or comments? Please let me know. Okay, otherwise, we conclude the calculation here. And as you see, we ended up very close to the max values here, actually, like with the thermal storage, it's just the 5,000 is reached. The hydrogen storage a little bit below, and also the import capacity a little bit below. So in principle, you should now have another calculation. Okay, maybe we should have a higher option for a bigger storage, then make new calculations. So yeah. I think that was what I was to say about the optimized improvements, and I hope you will find it interesting and work with it and use it.
Live, may I ask a quick question? It's
yes, please.
Nicola here.
Yes.
Nicola from Plain Energy. Yeah.
Correct.
Is it possible, or do you think it will be implemented in the future to set a dynamic range for the specific investments? Because, for example, if I try to optimize a thermal heat storage, then there is very large economies of scale effect when it comes to steel tanks. And it's not always possible in energyPRO when I use optimize to take that into account.
No, it is not possible today. I think also that was one of my points on the previous PowerPoint. We have one price at the moment, and then if this price is way off when you get your result, then it is going to be an iterative process where you kind of say, okay, as I seem to be in this range, then I change my price according to that, and then make new calculations, and in that way it moves ahead. But we do have developed methods for this, for having different price levels, so to speak, so that in this range of capacity we have one price, and in another range of capacity we have a different price. So you can make a stepwise calculation that way. We do have developed the methodology for it, but we have not implemented it. And also we are a little bit afraid whether it will be make a very slow calculation, but of course it would assist the user in getting a better result. But yeah, we have it on our map, so to speak, but has not included it yet.
Thank you.
Yes, welcome. Okay, then I think I will. I'll go on to this was the optimization. This was this investment curve we were talking about, Nicola, that we don't have. So but we would like to include that in a coming version. Okay, let me see if I can. So let's enter the next item. As a small but nice to have. Let me just show you what it does. Here it is. We have here that this is actually also one of our examples coming within energyPRO, where we have a battery included. Until now, we have only been able to put in a number here. So you have a capacity of 1 megawatt like this, and you could only put it in a number. But now we can formulate that. So I can enter, and then you have the list of functions as you do typically with formulas. I have made in this case, I have made a time series function called battery charging. This is the time series over here, and in this one it says 1. So here the result will be the same, 1 megawatt there, and then we also have 1 megawatt here. So now they are the same. I can make a calculation, and of course it was look very much as here we are. What do we see? Quite a lot here. I'll just turn off some of this. We see the battery down here. This is what's charged and discharged, and you see these values are 1.05 and 0.95. That is due to the efficiency of the charging and discharging. But here we have 1 megawatt, and then you see in this example we have a result of size 16,000 pounds, and then I can enter here and then change this number to like 5 megawatt, and I can make a new calculation. So now you see we have a lot higher charge and discharging values, and we improved our economy because now we are able to discharge and charge when the prices are good. So that's very basic what this does. As you see here, just to warn you, we have in the capacity you can use the function cycles, and actually if you click here, it seems like you can also use the function cycles here in the charging capacity, but that you cannot do at the moment. And the cycles is a number calculated by each calculation by each optimization period. So if you have monthly calculations, the cycle calculates returns how many cycles you have done in the previous months, and then that is used for your capacity of your storage of your battery in the next months. Yeah, that was not that complicated, this thing, but now you are able to do this, and you can do also more dynamic charging and discharging capacities. But in this way, actually, you can also define if you have periods where you want to charge and periods you don't want to charge. You can say that I only want to charge the battery if, like in this case, if my PV is producing or something like that, or I only want to discharge during daytime and charge during nighttime. Things like that you can specify now, because you can set this capacity. You can define that in this function here, either here or directly on in this formula here. You had all the options of using some date and time functions, and yeah, and if the radiation is above a certain level, then most likely you will have solar production, PV production. Then you can say, okay, then I want to be able to charge. Things like that you can use this functionality for. Any questions or comments for this? Okay, then I'll move on to the next item. So this is this peak payments in the MILP calculation. So that includes these three payments here: the imported fuel, imported electricity, or exported electricity. For these three items, we have had these peak payments. We have these peak payments for many years. But the new thing is now that the peak payment is actually included in the operation strategy and included in the MILP optimization. So let's have a look. I'll find another project. I have made a small example here. So this is a small one where we have a heat demand, we have a thermal storage, we have an electric boiler, and when we buy electricity from the market. We have two payments, a flat rate for the electricity, and then we have this user-defined payment here. So you select user-defined, and then you have on the list, on system level, you have this, here you have the peak import, peak export electricity, and peak import electricity. Here I have used the peak import electricity. I've selected the name of the market and set all periods. And then I define a price in euro per megawatt. So this will find at what period in this calculation did I have the highest import, the peak import, and then I multiply that in that amount of megawatt with this 1,000 euro. So let's and for now I have said, okay, this is not included in operation strategy. So this works as it always have. Let us make a quick calculation and have a look. So here we have 1 month of calculation where we have a demand, and then we have a electric boiler following this demand, and the consumption like that. So now we have a peak above 3 megawatt here. Look at the operation income report. You see this gives us a peak of 3.1. So this costs us 3,144 euros for this 1 month. Next, let's go in here again and now say, okay, now we want to include it in the operation strategy calculation. So now the MILP will try to minimize this peak in order to minimize the cost. So let's make another calculation. It's very fast. And you see now we have, it uses storage very much. And we have a capacity now of just below 2 megawatt. You see it here as well. And then if you look in the operation income, you see now that it's 2.0 here. Actually, it's a little bit below, as you see from the number here. So now our total operation expenditures has reduced. Our income has improved. Okay. So this peak payment here, this works. It finds the peak for the whole optimization period. So if you have this payment here and your optimization period is set to be a year, it will find the peak throughout this year and use that. Also, as you might noticed, we also have these 3 payments here of functions, which are annual peak import or export of fuel and electricity. So this is so that is that if you have a 12 months, you have a calculation which optimized by months. energyPRO will optimize each month, but then this payment will return the 1 month with the highest value and use that. So, yes, any questions or comments for this? No. Let me see. Then we will go to the last point, and that is related to some smaller improvements in the time series. Now we have added the option of modify a time series by on the time series being able to say the scale factor or an offset factor. Let me just demonstrate that. I have another example. Just a moment, I'll look it up. Take this one. This is also this one we use for the transmission optimization. Let's have a look at the time series we have over here. I'll go into this one. So here you see this is a wholesale electricity prices in Denmark for 21 in Danish kroner per megawatt hour. So it looks like this. Now we have another option down here, modifying time series. Now I can scale this and put offset. Now I would like to have this changed into be in euro per megawatt. So in order to do that, I need to use the exchange rate for euros from Danish krone to euros, and that is, let me just make sure I look it up correctly, 1,342. So for each Danish kroner, you get 0.13 euro. And then, of course, this makes no longer sense. So this is in Danish kroner per megawatt. So I'll change this here to euro per megawatt. And you see now we have around in the 300s or 400s. If I enter now, we are now quite far below, and it is in euros per megawatt hour. So this, and why do we have this? Because of course I could just as well make a time series function where I do this conversion. But the advantage of this is that if I'm never going to use these values, but always want them in euros per megawatt hour, then I don't need to add a time series function. This is very much used in the trade solutions where we have quite a number of time series and time series functions which need to be converted from one unit to another. So that's where we use this very much. Another to demonstrate the offset, like I have the ambient temperature here. That is in Celsius. I would like to have that in Kelvin instead of. So I would put an offset to it, 273.15 as I remember. And I'll change this unit here to Kelvin. So now we have this outdoor ambient temperature in Kelvin instead of. So in this way, with the modifying time series, you can modify your time series is an easy and convenient way. It is only for these simple values here. You can only put in a number. You cannot put in functions or formulas here. If you need to have more advanced conversions, you will need to do, as always, make a time series function for it. But this, in many cases, could save you setting up a time series function. Yes. The last topic of today is a small one, but nevertheless a nice one as well. I'll just maybe just hope it will be a little bit fast. I change to this one instead of where we have, you see, I would like to include now to show this the temperature, because as you see, the temperature is strongly related to the demand. And in this case, it's red here. Okay, so that's nice, but sometimes you want to have more time series shown and things like that. You want to control the color of this time series, and by now that is possible. I go in here, and we've added here this box up here. This is similar to the box you have on the ND conversion unit where you can select your color. Now you can also go on the time series. So I want to have some kind of green instead of, and then now it's green. Small thing, but also in many cases a convenient thing that you can control these colors. Yeah. Okay. I think that was it for now. Okay, then I think we will close down for today, and I would say thank you for listening in, and hopefully you will enjoy the new features here, and see you next time. Next time will probably be by the end of the year when we will introduce energyPRO 5.0, and for that we have a number of exciting news for you in that one as well. So hope to see you all again at that time. Okay then, see you all. Bye bye.